Hi, my name is Antti Kiuru. I work as the head of security assurance in the product security organization of Ericsson. Today I'm going to talk briefly about vulnerability assessments. So, what do we mean by vulnerability assessment? A vulnerability assessment aims to discover weaknesses in information systems. It's a process of evaluating a system whether there are existing known vulnerabilities. The weaknesses can be software vulnerabilities, privilege escalations, cross-site scripting, database injection vulnerabilities, and insecure configurations like default passwords and unprotected confidential files. A vulnerability assessment investigates and analyzes vulnerabilities and assesses a risk that the vulnerabilities pose. An assessment is needed to fix or remediate the vulnerabilities and resolve other underlying issues that might have been discovered. The discovery of these issues protects the system and its users against data breaches and unauthorized access. Sometimes the terms get mixed, and people think that the vulnerability assessments are the same thing as penetration testing. One big difference between a vulnerability assessment and a penetration testing is that a vulnerability assessment does not aim to exploit the vulnerabilities that are discovered like is done in penetration testing. Here I've listed what kind of steps there might be in a typical assessment. Scoping meaning that you need to know what you're doing, what your target is, what tools you're going to use, schedule the assessment, and secure needed permissions if it's not your very own system you're taking a closer look at. The testing could be white, gray, or black box testing. White box testing essentially means that you can utilize information about the network and the target system before testing, where black box testing means usually that you're going in blind and trying to gather as much information as you can to be able to do a proper analysis. Gray box testing means that you might have some information about the system, but might be doing the testing from an external point of view, from remote, meaning over the network. Discovery is performing the actual scan for vulnerabilities, be it scanning the network, the host, or the database system that you're assessing. In a host-based assessment, you're trying to identify existing vulnerabilities in a host or a system by using scanners that go through the system and list the possible vulnerabilities in software and libraries. In network-based vulnerability assessment, open ports are discovered with the network scanners and can sometimes fingerprint the system and its listening software for identifying and listing the vulnerabilities there may be. Database-based scans, you're trying to identify vulnerabilities that could allow injecting data into the database, which is called a secure injection. So what do we then use for discovering vulnerabilities? There are many options, and for some things you might have to build tools by yourself. There are different technologies and approaches that need to be used based on the target system that is being evaluated. Some of the tools are publicly available and they are quite easy to use and provide output that is understandable. Bear in mind that the output you get from the tools is not the same as the report of the assessment. Web application scanners aim to find vulnerabilities in, you guessed it, web applications. They test the web application's functionality and don't scan the application's source code. Some of the better known ones are OWASP's ZAP, coming from Z Attack Proxy, the Acunetics Vulnerability Scanner, and of course Burp Suite. Network scanners are used for mapping and identifying the open ports, and if lucky, fingerprinting them. The information can then be used to see if there are vulnerabilities in the applications that are listening for connections in the open ports. Many rely on Nmap, the network mapper that comes with many Linux distributions and is available for other operating systems as well. It requires basic knowledge of network protocols to get started. There are different variants that work in the same way, but Nmap is the one that's mostly used. It's also free and open source. Then there are fuzzers. Fuzzing is a technique that aims to discover weaknesses in how the target software handles invalid information as input. Invalid input could lead to crashing the system in such a way that it might lead to execution of unauthorized code in the target system. This is called a remote code execution vulnerability, and it's a severe vulnerability. It could also cause the target software just to crash. Those types of vulnerabilities are called denial of service vulnerabilities. Fuzzers can be built for purpose for testing protocols, APIs, basically everything that takes input and tries to process it. As part of the continuous integration and continuous delivery pipeline, security test automation can be implemented. This could be static analysis of the code, analysis of containers, input validation tests, and so on, not forgetting testing of authentication and authorization calls. There are some caveats to automated testing that a penetration testing of the system might reveal later. They can come short in detecting vulnerabilities that can be chained together for a bigger impact. Now let's say that you have now completed a few scans and have a different kind of set of outputs to start building your report from. You have a nice multi-page list of different identified issues and vulnerabilities. So how would you go on about rating them and know what to highlight in the report? Vulnerabilities can be ranked or prioritized based on different metrics, for example, to low, medium, high, or critical priority. These kinds of prioritizations differ from organization to organization. The industry standard one is called CVSS, or Common Vulnerability Scoring System. CVSS is based on calculations that consider attack vector, meaning where it can be exploited from, attack complexity, meaning how difficult or trivial is it to exploit the vulnerability, what kind of privileges are required to exploit, what kind of user interaction it requires, its impact on confidentiality, integrity, and availability, as well as the scope, which refers to the possible impact beyond vulnerable components, security scope. CVSS version 3 also takes into account temporal metrics as well as environmental metrics, which are unique to a particular user's environment. CVSS base metrics produce a score from 0 to 10, which can then be modified by temporal and environmental metrics. The CVSS scores are a quick way and an easy way to get a grasp of how serious vulnerability you're looking at. So, if something, for example, has a CVSS score of 5.0 and it is exploitable from a local machine only, it gets a different kind of reaction from system administrators and developers than something that has a score of 10.0 and is exploitable from a remote location without any authentication. Vulnerability assessments and scans should be done periodically or in connection to new releases of software. As it is quite time-consuming, consider automation where possible and when working in a DevSecOps culture. Scanning is only one part of the assessments. Reporting is the key to delivering the message about identified weaknesses and vulnerabilities. Without a proper report, the message gets lost easily, and sometimes the people who should get the message are not technically savvy enough to understand the technical details of the vulnerabilities. Vulnerability assessments serve as a background for evaluation of security posture of the system or product that you have in your hands, and it makes the life of a penetration tester much easier. If they are done periodically, one might start to see patterns in things that always emerge in the assessment reports. And thank you for following. I hope this was useful and interesting to you.